So yesterday we have introduced the some fundamental knowledges about the stress and strain analysis with respect to the rigid pavement, the curling and the warping effect from the temperature and moisture contents. And we also making a brief introduction about the Westergaard's equations, which will be applied for you to find out the closed form equations of the stress and strain for the rigid pavement. Basically, the Westergaard analysis will only be applied for three specific situations: the corner load, the edge load, and the interior load. For all these three scenarios, we will consider the concentrated load and the circular load. For the concentrated load, it means that we will only apply the load to a specific point. For the circular load, means that the load will be applied to a region, and in this case, we will consider a circle. And in this figure, you can actually see these three different situations. This would be the interior load. This is the corner load. This is the edge load. Each one will have different impact about the performance of the pavement. And first, for the corner load, we will focus on the concentrated corner load. And in this situation, we will have the force applied, a load applied to the corner of the PCC slab. And with the Westergaard equation, we can find out the stress at any locations which will have the perpendicular distance to the corner of X. And this can be the equation here shows the stress applied to the red line, as shown in this slab. All the points in this red line. And of course, in these equations, we will apply the same definitions of the variables. H is the thickness of this slab, and the A will represent the cross-sectional area. That would be 2x times H. That is the cross-sectional area. This equation actually comes from the Carty level. Will be performed comes from the stress analysis from the Carty level beam, and you will see some similar equations in the class about the statics or dynamics. So that's the first one about the concentrated load, and for the second case with the circular load, where the load is applied to an area, to a circle within the radius of A, then we can also try to estimate the stress applied at the same situation, the same locations with the distance about X to the corner. And this equation shows the stress applied at the location where we will consider the value of little l, and it will shows you how to calculate the stress at the specific location with the distance x to the corner. And with the one with the Westergaard equation, you can actually find out the deflection. You can also apply another equation, which is called the Arnold's equation. That one comes from the finite element methods. It will give you a similar equation, which will give you the estimations of the stress and also the deflection. This one actually applied at the situation when the contact area is assumed to be in the square instead of the circle. And in this equation, C will be we have an equation relationship between C and A, the radius of the contact area, circle contact area, and C is the side length of the square area. So that's for the circular corner load. And in the equation, we have the little l. Little l is defined as the radius of the relative stiffness. We have defined this one previously. As a function of the thickness of the slab, the modulus of elasticity, Poisson's ratio, and the modulus of the subgrade reaction. And also we can identify that the areas which will be affected by the load will be 5 times little l. So we have a specific range to consider. Outside this range, we don't need to think about the impact or the stress and the deflection applied by the circular load. So that's for the corner load. For the interior load, we have different equations. The interior load indicates that the load is applied at the center of the PCC slab. This one, usually for the interior load, is less critical than the corner load because they will have the support from the other side, from the surrounding areas of the slab, and it will less likely to cause the distress from the PCC slab. With the interior load, we can calculate the stress with this equation, and of course here you need to consider the thickness of the slab, the concentrated load, the Poisson's ratio, and the values about the radius of the relative stiffness, little l, and also you can you need to use the coefficient b, which is determined by the radius of the contact area and also the thickness. And we are also able to find out the deflection caused by the interior load. And this is the Westergaard equation for the interior load. And we can also go to check the impact of the edge load. The edge load indicates that the load is applied at the edges of the pavement. And for this specific situation, we will consider 2 different loads applied. One is the full circular load. The other one is the semicircular load. The full circular load indicates that the tire will be the load of the tire will be totally applied to the slab, which will be like the circle here. The semicircular load indicates that only part of the tire or the contact area will be applied to the slab, and the other half is actually outside of the slab. For these 2 situations, we can find out calculate the stress and the deflection from the load of the P based on the contact areas, the radius of the relative stiffness, and also the thickness of the PCC slab. And if you have the semicircle load, then you need to change the coefficients to calculate the stress and the deflection. Usually for the edge load, it's more severe than the corner load and the interior load. So this is we will usually need to think about the impact of the edge load to find out the maximum or the capacity of the PCC slab to support the load from different groups of the truck flows. So with that, I will quickly summarize. I have quickly summarize what we have learned about the stress and strain analysis of the pavement. In the previous several lectures, we introduced the way for us to calculate the stress and strain of the flexible pavement. We have some theoretical methods based on the Bosniak solution, Burmester solution, the Oldmark approach to calculate the stress and strain at any locations. In the flexible pavement, we regarding to the rigid pavement, for the theoretical solutions, we just focus on the Westergaard's equations, using the Westergaard equations to calculate the stress and the deflection applied to the PCC slab, either through the corner load, interior load, or the edge load. And we also have some analysis about the impact of the temperature and the moisture contents to the stress and strain of the of one PCC slab. So that will be all the contents about the analysis of the stress and strain. And with that, I will conclude the chapter about the stress and strain analysis of the different type of the pavement structures. And do you have any questions so far? If before I go to the introduction of the KenPave software. Okay. If you have any questions, just feel free to raise your hand or leave your message in the meeting chat. Okay. So for the now for the KenPave software, this is actually one software developed by Dr. Huang, which is the also the author of the paper, a key reference paper that we applied for this class. And it's pretty helpful for us to analyze the stress and strain for the flexible, under the flexible and rigid pavement. Actually, it could be more general. You can apply it for the flexible pavement with multiple layers. For the rigid pavement, you can analyze the stress and strain from multiple locations simultaneously. With that, you can simplify your analysis and the design of the pavement a lot. So to use the software, you first need to download the installation package that I uploaded on Avenue to Learn. I will just skip that and give you a demonstration about how to use the software to solve some problem. In this demo, I will just go through the example. Just go through the example that we, not this one. Go through one example. So here we will consider a 5-layered elastic system, which would be a flexible pavement. We know the properties of each layer. For the surface layer, the is an asphalt concrete mixture with a thickness of the 4 inches and elastic modulus of 350,000 psi. We have the Poisson's ratio of 0.2, and the density is 150 PCF. We also know the thickness, elastic modulus, and the Poisson's ratio for the base course, subbase course, the crush aggregate subbase course, and the subgrade layers. So here, in general, we will have 5 layers, and the problem wants us to determine the state of the stress and strain and the standard load, which would be 18 kilopound or 80 kilonewton. Is also a single axle load, and the tile pressure is 85. It's 85 psi, and just draw this one. 85 psi, and we also know the spacing. The spacing between the dual tire is 13 inches, and we want to examine the difference on the stress status if the tile pressure increased to 120 psi. So we want to consider 2 different analyses. And this one also gives you some information about the, this figure also gives you some information about the pavement structure and the axial structure. And we're going to use the KenPave to do the analysis. So with that, I will switch to my other computer for the for the demonstration of the KenPave software. Let me share my other screen on my other computer. Okay, so I hope you can see my screen now. And okay, and first of all, I just assume that you all have already installed the KenPave. So if you have already installed it, you can just activate KenPave directly. And now we're going to work on the flexible pavement first. So what we do is like we will first go to input all the informations from the problem. We're going to choose the asphalt part. That will be all the buttons on the left. For the input information, you need to select the layer input. And now you have the new window, which is the main menu for the layer input. First thing you need to do is go to define a new file. So for this case, we're gonna go to the file and select new. And now you have a new file, and you can see that the title of the file is not defined yet, but that's fine. We're gonna define the title later. And next, you need to go to check the other input information. First, go to General. If you type General, you will be asked to type the title of this project or the problem you're trying to solve. For this case, we say that 4G 4G04 5-layer example. And you can define any title by yourself. And there will be some other parameters you need to input for this situation. First is the type of the material. You can see that there will be 4 different variables: the linear, nonlinear, physical, elastic, combined. In this case, we will try to simplify the analysis. So we just choose the linear materials, and it indicates that the property, most of the property will be constant for the pavement, including the modulus elasticity, the coefficient of the subgrade reaction, and so on. And the second row tells you whether you want to do the damage analysis. This one is related to the pavement design, but we haven't go through this one yet. But in the problem, we don't need to do a damage analysis, so just type 0. And the number of the period you want to analyze per year, usually we choose the value as 1. And the next one is the number of the load groups, which will tell you how many groups of the trucks you want to analyze, or how many groups of the load you want to analyze. For this case, we only have one group, the single axle load, standard single axle load. So we say that the group number is 1, and the tolerance for the numerical integration. This one indicates how they're gonna do the because they apply the finite element method, so they will do the iteration and they will try to check what's the potential errors they can accept. The default value is 0.001, indicates that they want the error to be less than 0.1%. You can choose something larger, something smaller, depending on the tolerance to the error. And the next thing, which is very important, is about number of the layers you want to analyze. For this problem, we want to analyze 5 layers. Let me try to bring out the questions. We want to do the analysis for 5 layers. So we choose the number of the layer as 5. Also, we want to the next thing we want to analyze the number of the z coordinates for analysis. In this specific case, we want to do analysis about the stress and strain at all the interface between the layers. So we will have 1, 2, 3, 4, 5 different locations, 5 different depths we want to analyze. So with that, we will also type this value as 8, as 5. And the next number is the maximum cycle of the numerical iteration. It will tell you how many iterations what's the maximum number of iterations you will do. The default value is 80. And the next one is the type of the response you want to generate. If we choose 1, it means that you will only see the displacement, which would be the deflection. If it's 5, it means that you want to do also do the analysis about the stress. If it's 9, it means that you will include displacement, stress, and the strain. Well, here I will just try to make it simple. Choose this one as 9. In that sense, you can see all the informations. And the next thing is about the layer interface, whether they are bounded or not. For this case, they will be bounded. And we also have the number of the layers at the bottom of the number layers for bottom tension, and we just choose the value default value as 1. And the next one, the number of the layers for the top compression, keep the default value as 1. And the system unit, if whether it's a EI or SI, here we have the inches, the pounds, so we're gonna use the English unit system. So that's 1. Once you type all this information, click OK. So we will down the general input, and you will observe the down here. And the next one is the z coordinates, which indicates that what depths you want to do the analysis. In our situation, we want to do analysis at the depths with respect to the interface of the of each layer. So for this specific case, we want to do the analysis at the surface of the pavement at the bottom of the first layer, bottom of the second layer, third layer, and the fourth layer. So the depth of the first point will definitely be 0 inches, and the second one would be 4 inches, and the third one would be 4 plus 6, that would be 10 inches. And the fourth one would be 4 plus 6 plus 6, that would be 16 inches. And last one would be 28 inches. So that one will tell the system, tell the software at which depth you want to do the analysis about the stress and strain. Okay, and with that, you have done the input about the depths, the z coordinates, and then you need to input the information for each layers. So you're going to go to type the thickness of each layer. For this problem, the top layer, the thickness is a 4 inch, and the second one is a 6 inch. The third one is a 6 inch, and the fourth one is 12 inches. And we also need to capture the information of the Poisson's ratio, which would be the PR here. The Poisson's ratio is for the top layer, it's 0.2. The second one is 0.3. Third one is 0.4. And the fourth one is 0.4. And last one is 0.45. So that's the information about the property of each layer. And then click OK. And now you need to get more information about the modulus of elasticity. Type the modular. And there will be a period. If you choose multiple periods per year, then you will have multiple buttons available. But if for this case, we only have one period defined for each year, so you're gonna only observe period 1. And then in the period 1, you need to type the modulus of elasticity for each layer. For the first layer, that will be 350,000. So 350. And the second one is 150,000. And the third one is 85,000. And the first one is 120,000. And last one would be the subgrade layer. It's 5,000 as a 5,000 psi. And with that, we done the input of the modular. And once you finish this one, click OK to turn off the modular window. And the next thing we need to do, which will be final input we have to consider, is the load. What's the load applied to this flexible pavement? And here we actually only have one group of the load, and for the first one, so with that we only have one row, and in this row we will have several columns which will indicate different features you need to input. The first one is the load. You need to type the type of the load that applied. If it's 0, it means that a single axle with single tire, and if it's 1, it indicates that that will be the single axle with a dual tire. And if it's 2, means that a tandem axle. If it's 3, means that the trident axle. For this problem, we define this one as the standard single axle load, which will be the single axle with dual tire. So we have to choose the value as 1. And the next thing will be the CR. CR represents the contact radius of the circular areas of the circle. And we define the contact. We haven't specified the contact area in this problem, but we can make an assumption about the well, this problem does not specify the contact area, did not specify the values of A. With that, you need to make an assumption about what's the contact area is. So we can say that the contact area is some general values of the contact area, which would be 4.11. That's the common value for the standard single axle load. And the first one, CP, represents the contact pressure. In this case, for the first situation we want to work with, that will be 85 psi. So we will type 85 psi. And then the next thing is the YW, which will be the center to center spacing between the two dual wheel along the y-axis. For this case, it's along the y-axis as 13 inches. And for the x-axis, well, the value is 0. And the last thing we want to consider is the number of the point we want to analyze, which would be the MP. And here you can see this figure. We want to analyze the stress and strain at 5 points: 1.1, 0.2, 0.3, 0.4, and 0.5. So here you just type 5. And one tricky part at this step is like once you type the number here, you cannot use your mouse or cursor to click at any other place. Instead, you need to press Enter in your keyboard. Once you press Enter in the keyboard, you will be asked to go to the a new place, which will tell you the location of where the location is. The location of those points is specified. So for the point 1, that will be 0, 0. That will be fine. Point 2, it's between is in the middle point of the two tire, so that will be 0, 6.5. That's the value of inches. For point 3, it's just at the edges of the left tire, so the value is the radius of the contact area, that is 4.11. And for 4, it's the spacing between the two tires, which is 13. And for the last one, that will be the 0.5, which is the left edge of the right tire. That will be 13 minus 4.11, which would be 8.89 inches. And this would be the information where you want to do the analysis. With that, you can click OK to complete input the information of the points you want to analyze. And then you finish the input of the loading information, press OK. And the next thing you need to do is save this file, save this you can choose save as, and then save this file to the to some photos where you can recall. We will save the file as 4G04 file layer example. So that's the file we're gonna save. And I also know where it's saved. It's saved under the folder of KenPave. And then press save. Okay. And then exit the input. Now the next thing you need to do is apply the Ken layers to do the analysis. So press the button of the Ken layer, and this one will help you to do the analysis about the stress and strain at or with all the information you defined. So with that, you finish the computation, and you can press OK to exit it. Also, you can find where the file is stored. It's stored under the KenPave folder with the 4G04 file layer example.txt file. So that's the all the values, and press OK. And the next thing is like you can go to check the output file. Go to the editor and select the file and open the file you just saved, which would be the 4G04 file layer example. And this would be the information you should observe. And at the very beginning of this file, there will be some information that you input the input information they present here. And then you will have the information about all the points that you want to analyze. And for the first column represents the point number. The point 1, you have five numbers which will represent the stress and strain at 5 different locations, 5 different depths at point 1. So you can find out the displacement at the surface, which would, if the vertical coordinate is 0, means that the surface if it's 4 inches represented at the bottom of the first layer, 10 inches at the bottom of the second layer, and so on. You can find out displacement at the surface at point 1 is 0.0, 15, 18 inches, and find out the displacement at the second at the depth of the 4 inches, 10 inches, 16 inches, and 25 inches. So that's the displacement. You can also find out the vertical stress at different depths at point 1, and followed by the strain at different locations. And also you can find out the major principal stress, minor principal stress, and intermediate principal stress. Find out the principal stress at 3 different directions. So that's for the point 1. You have 5 different output for the point 1 at different depths as you specified. And you can also find out information for the other points, point 2, point 3, point 4, and point 5. And so that's for the first scenario. We do the analysis about the stress with 85 psi for the tile pressure. And I will leave the second scenario for you to do by yourself with the tile pressure of 120 psi. And you also can go to the tutorial. You can go to the tutorial. There will be some examples about how you're gonna do the analysis for a 3-layer system. So this is a simple case, a 3-layer system, to analyze the stress and strain at multiple points at here they want to do analysis at 12 points, and it can follow their steps to complete the analysis. And another useful tools from this software is like you can even draw a graph about the entire analysis by clicking the L graph, which will show you the scenario that you analyzed. You can try to print out the graph from some softwares that you have, or just connect to your printer. And here you can find out all the informations, where the tile is located, what's the information of each layer, and what's the thickness of each layer, and so on. And also you have the load information, the contact radius, contact pressure, the dual spacing, and this pink point represents where you want to do the analysis about the stress and strain. So I'm going to exit this one. And this is about the analysis of the flexible pavement with the KenPave. For here, I will pause for a while to get any questions that you have. Do you have any questions so far regarding to the software? I will also recommend you to do some practice by yourself after the class to go through the example in the tutorial. Also, if you want, you can use the KenPave to analyze the stress and strain for some examples that I listed in the lecture, in the course notes. Okay. So that's for the analysis with the flexible pavement. Well, we can also apply the KenPave to do the stress and strain analysis for the rigid pavement. And to do the analysis in the rigid pavement, you need to go to the buttons on the right. So for those buttons, the slabs input, the Ken slabs, they will be applied for the rigid pavement. First, similar to what we do for the flexible pavement, we need to input the information. And I will just go through this instruction quickly. First of all, you can generate a new file, and then type all the information. But here I already have some files which has already been generated. So I will just choose some old files. This will be some examples from the KenPave comes with the KenPave. You can choose the slab example. Choose a slab 6, and then you can go to find out go to check the input information. First, for the general information, you need to define the title of the project. So this is the raft on the solid foundation with the retaining walls on the 3 sides. And then you need to go to input the properties of all the features of the project. The type of the foundations, which would be the type of the subgrade. It could be the liquid, it could be solid, or the layer. The liquid means that you will consider the subgrade layer as the wrinkle spring, which would be the most common assumptions we made. You can also consider the subgrade in the solid. Well, for this example, it's in the solid. And then you can specify, I don't want to do analysis about the damage analysis. And the number of the period is 1, number of the load group is 1. All those things will be similar to the flexible pavement. The only thing you want to further you want to pay attention to the number of the slabs. For the rigid pavement, we don't want to do analysis about the layers. Instead we want to analyze the stress and strain with respect to the different slabs. You can analyze multiple slabs. If you have multiple slabs you want to do, it specifies a maximum number of the slabs that you can analyze. So the maximum number is the maximum you can have 6 slabs to be analyzed simultaneously. And for this example, it only has 1. And also the number of the joints, if you only have 1 slab, definitely you only have 1 joint. And the other thing you want to analyze is you want to input is the number of the nodes you want to analyze in the x direction, the number of nodes you want to analyze in y direction. That will be the column here, the row here and row here. For this example, it's set as 11 for the x direction, for 0 for the x direction, and 11 for y direction. And also, it will specify some load information, whether you have the uniform load or the concentrated load. If you have uniform load, then you click with uniform load. If you have the concentrated load, you're going to click with with concentrated load. And you also can think about whether you want to include the temperature curling effect, or you can decide to not include it. In this software, we did not include the impact of the moisture contents because that one is more complicated. That's the reason we usually discard the analysis for the moisture contents for the rigid pavement. And once you have inputted everything, you just click OK. And then as you don't have any curling effect there, so you don't need to do anything. But if you have the temperature curling effect, you can select the make some selections about the coefficient of the thermal expansion, the tolerance of the tolerance for the iterations, and also the temperature difference between at the top and bottom of the slab. Because here we don't have any information, so we don't want to analyze the temperature impact, so we select the value as 0. If you have any temperature curling effect you want to analyze, you can choose the temperature difference. The default value, usually the value is around 20 degrees, depending on the regions and the type of the materials. And click OK. And the next thing you need to analyze is the slab. This is the most important part you want to input for the rigid pavement analysis. First, you have to choose the arrangement. In the arrangement, you need to define the number of the points, the number of nodes in the x coordinates, and the number of nodes in the y coordinates. I guess I typed something wrong here. Just let me change it back. Okay. So they have the 11 at the x coordinates and the x direction, and they have 10 at the y direction. So the maximum number will all be 15. And once you type the number, click OK. And then for the x coordinates, if you click x coordinate, you will go to select the property about the points you want to analyze for the x coordinates. As we only have 1 slab, so there's only 1 button here, but you can get up to 6 slabs. So we have selected 11 points, and this would be the width, the length of the slab. The total length is 600 inches, and you can divide them evenly, or you can specify any specific intervals by yourself, but it will cover all the width of the all the length of the slab. So here it's evenly displayed. It's 0, 60, 120, 180 until you go to 600. And this is about the x coordinates. And similarly, you need to go to the y coordinate to see how you're going to differentiate them. And for the y coordinates, they have some specific settings. For y coordinate, they want to specify they have 10 points want to analyze, so they have uneven intervals. The total width of the slab is 460 inches, and they have specified the point they want to work with. They have 20, 75, 130, 185, and so on. This is based on the requirement from the problem we want to analyze. And click OK. And the next thing is the property, which is also the information you want to input. So it will include the thickness. T will be the thickness of the slab. Is for this example, it's 20 inches, and the PR is the Poisson's ratio. It's 0.15, and the Ym is the Young's modulus, which will also be the modulus of elasticity. This would be the information of the slab. And click OK. You finish the input about the slab. And next thing is the uniform, which will tell you the load you're gonna apply. And in this example, we have two different load groups. If you go to type the number of the load groups, click Enter. You can type the information about the load group, and it will tell you what's the load applied and where the location where the load is applied. And you have two load groups. The LS indicates the type of the load, and this would be the represent the slab number, which slab is applied. We only have one slab, so the both of them will be 1. And the XL is the left limit of the loading area. XL2 is the right limit of the load area. YL1 is the lower limit of the load area, and the YL2 is the upper limit of the load area. And you also have the QQ, which will be last column, shows the load, the contact pressure applied at this from these two different loads. And once you type the information, click OK, OK, and then if you are done the input of the uniform the load information, and the next thing is the number of the central concentrated force. This, if you have any concentrated force, you type the information here. And the optional, for the optional, you will need to specify the where the point it is. So you have the at the y coordinates you have 11 points, so it's sorted as 1, 2, 3, 4, 5 to 11. And then you click OK, finish the input. And now for now you finish everything, and then you're gonna save the data. Well, this is not the you're gonna save it, and then gonna exit this one, and then do the analysis. So what you do is that you will just click the KenPave to do the analysis. I guess I have the wrong file input. Just so we'll try to do everything. I'll just still use the file that we have, and then type everything, and we're gonna save this one, and then exit this one, do the KenPave, and with that you finish the analysis. And similarly, you can go to the editor and open the file. This is the output file, the slab 6. And with that, you can get all the information, the stress and strain at all the points is specified here. They defined a lot of points there, and eventually can find out the maximum stress, the minimum stress applied. Maximum is minus 78,000, minimum is 24. They are talking about some absolute values. You can also have the maximum stress, maximum moment at the y direction, and minimum moment at x y direction. And so that's the output information. You can basically find out all the information you need about the stress and strain for any location is defined. And you can also go to the G-graph to find out where the maximum stress is for this example. And also you can go to the contour plot to see the stress and strain distributions over the entire slab. I go through the rigid plate very quickly. You can also go back to check the manual to see how we can use understand all the input information for the rigid place. But basically, for the flexible pavement, the KenPave software is very important. It's very useful for you to do analysis of the pavement, the stress and strain at multiple layers. Okay, I think I run over the time. So with that, I'm gonna stop the presenting the materials. Do you have any questions you want to add? If no, then I will probably close the meeting today. And after the lecture, you can go back to do some practice by yourself and try to learn how to use the software to solve some complicated problems, some examples in the tutorial or in the example I shared in the lecture today. Okay, if you don't have any questions, I will close the meeting today, and I really appreciate your time in the class. With that, I will close the meeting, and I will see you next week. Okay, great. Enjoy your weekend, and see you.